This is the second video in the series about deriving the exact values of sine and cosine of some special angles. So from the first video, we saw that the cosine of 0 was 1, the sine of 0 was 0, and that the cosine of pi over 2 was 0, and the sine of pi over 2 was 1. In this video, what we're going to do is we're going to look at the ordered pair that's right in the middle. So I'm going to basically cut this quadrant in half with an angle that I know the measure of. Since it's exactly halfway through that 90 degrees, this is going to be a 45-degree angle. Or if I'm using radians, since it's going to be half of pi over 2, that angle is going to be pi over 4 radians. And what's great about it is it's exactly halfway through the symmetric segment of the circle. I didn't draw it that it looks like this stuff up here is the same as this stuff up here because I'm using my finger to draw it, but everything up here is exactly the same as everything up here. These sides are the same. These sectors are completely the same. That arc is the same as that arc. Everything, the angle is the same, all of that. So what I'm going to do is I'm going to look at how high that is, and that's going to be the y-coordinate of this ordered pair. And I'm going to look at how far over that is, realizing that they're the same. That whatever this is, and I'm going to call that length A, whatever that is, it's exactly the same as that. But this is really a square that I've drawn. So I'm going to focus just on the square. So I'm going to draw the square, side length A, and I know the hypotenuse is the diagonal here, and it's a unit circle. So that hypotenuse, or the diagonal of this square, is length 1. That's really going to help me, because if I look just at this lower right triangle, that side's the same as that side, it's the square. So all 4 of these sides are A. Here's a right triangle that has legs equal to A, hypotenuse equal to 1. Pythagorean theorem says the sum of the squares of the legs is equal to the square of the hypotenuse. Now in general it's a squared plus b squared equals 1, but in this case the legs are the same, so let's call them A, call them each A. But doing some algebra on this equation to solve for A, got 2a squared equals 1. Divide both sides by 2. Got a squared equals 1 divided by 2, or half. Take the square root of both sides. And usually I'd take plus or minus, but this is a length, so I'm just going to take the positive square root. It's an equal sign in the middle there. And typically in trig we rationalize denominators, so I'm going to go ahead and multiply top and bottom by the square root of 2. And so 1 times the square root of 2 over square root of 2 times the square root of 2. That's the square root of 4. That's just 2. So awesome. I have the length of the side of this square. Looking back on the unit circle, I have that is square root of 2 over 2, and that is square root of 2 over 2. But those are just the coordinates of this dot. And therefore those are just the cosine and sine of that angle. So this one's the cosine of pi over 4. This one's the sine of pi over 4. And let me actually erase this stuff, get it out of the way. Okay, let me summarize that. So we have quite a bit of stuff so far. We have, just now we saw that the cosine of pi over 4 is square root of 2 over 2, because the x-coordinate is square root of 2 over 2, and also the sine of pi over 4 is the square root of 2 over 2, because the y-coordinate of that dot was square root of 2 over 2. Put that together with what we knew before. Cosine of 0 is 1, sine of 0 is 0, cosine of pi over 2 is 0, and the sine of pi over 2 is 1. Well, it's a lot of exact values. We've got more. See you in the next video.